12.5, volume of pyramids and cones. All right, for this one, we have the volume of a pyramid. It says the volume of a pyramid is 1/3 the area of the base times height. Or what we have is volume is equal to big B, or excuse me, volume is equal to 1/3 big B multiplied by big H. Okay, this is basically the same as when we were looking at our right cylinders and right prisms. When we have our pyramids, though, the area of the base, it's always going to be a little bit different. Here we have, right here in 1, we have a square, so we have to find the area of a square. Here in number 2, we have a pentagon, so we'd have to find the area of the pentagon, so that would be our big B. And so on 2, 3, and 4, we'd have to use our area of a regular polygon, which is area is equal to 1/2 the apothem multiplied by the number of sides times the side length, so N and S. When it's talking about the height of the pyramid, so I'm going to come up here to number 1. I'm going to erase number 1 to show you what they're talking about when they say the height. Back in 12.2 and 12.3, we were talking about slant height, and that went along the face. But we need to find the big H, so the actual height. The actual height of the pyramid drops down from the center, or the vertex, down to the center, creates a right angle. And that is the actual height, so the big H of our pyramid. So that is what we're talking about when we're saying the big H. If we're looking at the volume of a cone, that is also 1/3 times the area of the base times the height. So volume of a cone is also 1/3 big B times big H. And just like the cylinder, the base every time in a cone is going to be a circle. So our big B is always going to be pi r squared, which is the area of a circle. All right, example 1, it says find the volume of the solid. So when we're finding the volume of the solid, we need to find the volume of the pyramid. Remember, the volume formula is equal to 1/3 big B times big H. So we have to bring down our 1/3. In brackets, I'm going to put the big B. So the area of the base. Now our base in this pyramid is a triangle. So the area formula for a triangle is 1/2 the base. So the base here we're going to say is 4, and the height is 6. Those two you could, if you wanted to, flip those, because what we have 4 and 6 run here, but between them is a right angle. So we know those are going to be the base and the height. I use 4 for the base and 6 for the height. And that's because they have the right angle running between them. Now we need to find the big H. So the big H is the entire height of the pyramid, which is 9. So I'm going to find what's inside of the brackets first. So I'm going to bring down my 1/3. That's a big mistake. A lot of times I've seen students not carry down the 1/3 every time, and they'll end up getting the wrong answer. So remember to always bring down your 1/3. So inside of my brackets, I'm going to have 12. And I'm multiplying all this by 9. So now, basically, you can plug this in your calculator. You can just you can simplify it from here. I'll do 12 times 1/3, which is 4, times 9. Final answer is going to be 36, and it's meters cubed. We have volume. We're looking at the volume, so we're going to have our units cubed. So in this case, they told us units are meters, so we have meters cubed. Looking at the next example, we have a cone, so that's going to be volume is equal to 1/3 big B times big H. Big B stands for the area of the base. Big H stands for the entire height of the three-dimensional object. So we have, bring down our 1/3. The big B, remember this is a cone, so the base is always going to be a circle. So we know that our big B in a cone is going to be pi r squared. Our r stands for radius, so that's 2.2 squared. Finish all my brackets, and the height here is going to be 4.5. That's the height of the entire cone. So 4.5. Now I can plug this in. So what I'm going to do, I'm going to have 1/3. I'm going to find my big B first. So remember, go out at least 4 decimal places. So I have 15 times, or excuse me, 15.91976. So when you multiply, you're going to have 15.1976 multiplied by 4.5. And at this point, I would suggest just plug it into your calculator. So after you plug it into your calculator, you are going to have 22.9 0.7964. And this is centimeters. They told us centimeters. And it's volume, so it's cubed. So there's your final answer. If you had something like 22.8, that would be fine as well. But like I said, try to keep it as exact as possible. Okay, our second example. It says, originally the pyramid had a height of 144 meters and volume of 2,226,450 cubic meters. Find the side length of the square base. So, I would suggest, first off, always drawing this. We have a square pyramid, so I'm going to try my best here. We have this goes up. Here's my pyramid. And my drawings are not very good. I don't expect yours to be perfect either. But it told us that the height, so the entire height, the one that drops down, goes through to the center, creates a right angle here. That is, this dimension is 144. And I know my volume. My volume is going to be equal to this guy. So I draw a little line up here, a little arrow, so I know that's my volume. Okay, now we need to find the side length. So we're looking for S. Okay. What I'm going to use here, they gave us the volume, so I'm going to use my volume formula. So I have volume is equal to 1/3 times big B multiplied by big H. So I can plug in my volume. I know my volume is 2,226,450. And I set that equal to 1/3. Now the area of my base. So the area of the base. Well, we don't know that. That's what we're looking for. We're looking for one dimension of that, but the area of a square is going to be S squared. But instead of S, I'm going to use X. You could use whatever you want. I'm going to use X, so I have X squared. So that's my big B. And then big H, the height they told us is 144. So multiply all this by 144. And now it's become an algebra problem. So I have on the right side, I'm going to multiply by 1/3 by 144. And that's going to give me 48. So I have 48 x squared. And I have my 2,226,450. So I divide each side by 48. Divide each by 48. So on the left side, I'll have 46,384.375 is equal to x squared. To get rid of a squared, we take the square root. So when we take the square root, we're going to have x is equal to, and we have 215.37. It's a dimension, so it's just going to be meters. So 0.37 meters. Okay, so this problem was a little bit more involved. We had a word problem. We had to draw the picture to the best of our ability, use the volume formula, all the way down to get our side length. Alright, example 3. This is probably the most difficult example that we're going to have today in the video. So it says to find the volume of the right cone. Well, we're finding volume. So I know my volume is equal to 1/3 big B times big H. So I have 1/3 big B times big H. So I can bring down my 1/3. I know that. Now when I'm looking at my big B is going to be in brackets once again, and I know it's going to be pi r squared because we have a circle on the base. So I know I have pi. However, I do not know my radius. So r here, we don't know the radius. What we do know, we know one side length, 16, and I know the degree measurement of one of my angles of my triangle. So this is a right triangle, so there's special properties we can use. A lot of you guys are probably just took a mental sigh because you know what's coming up now. So we have our triangle here. What we need to find is r. To do that, we're going to have to use trig. So if we use our trig, I'm going to say that I have, we're trying to find r, so I'm going to blow up my triangle here. So I have r, and I have 16, and then my angle measurement inside of here is 65 degrees. So the trig that I would use for this, I would have to use tangent. So I have tangent of 65 is equal to, and it's opposite over adjacent. So we have our opposite here. That's how I knew how to use tangent. So I have opposite and adjacent from my known angle. So from my 65, the opposite is 16 and the adjacent is r. So opposite over adjacent. And now what we can do is I would find the tangent of 65. So we're going to have 2.1445 is equal to 16 over r. I would suggest putting this over 1. And now you can cross multiply and divide. So r is going to equal 7.4609. Hopefully you guys are noticing in both of these I'm going out at least 4 decimal places. I'm trying to keep this answer as exact as possible. So if I come up here, I can now plug in my r. We know it is 7.4609, and I can square that. So we have our pi r squared. Now I need to find the entire height. Well, they gave that to us. They told us that's 16. And so from this point, once again, you could multiply all this out in your calculator, and when you do, you should get 932.22, and that is going to be feet cubed. 932.22 feet cubed. And that is the volume of the cone. Here, example 4. Example 4 is a bit of a challenge problem. However, what I'd like you guys to do here is I'd like you to pause the video, try to find the volume of the entire solid on your own. Okay, hopefully that was enough time. Let's go over this one. So I'm going to break this down into parts. The first part, I'm going to call this part 1. I'm going to call this part 2. So part 1 and part 2. I'm going to start with part 1. So I have a cube. So the volume of a cube is equal to side cubed. I know it's a cube because all of our dimensions are the same. 6 here, as well as 6 here. So all my dimensions are the same. I know I have a cube. So to find the volume of this, I would do 6 cubed, and that would give me 216. So there's the volume for figure 1. Figure 2, what we have up here, we need to identify first off what figure that is on top, and that is a pyramid. So we have a pyramid on the top, and it's not just any pyramid, it's a square pyramid. Remember, we need to be as exact as possible when we're describing all the solids. So I know the volume formula for that is 1/3 big B times big H. So we're going to bring down the 1/3. Big B, I have a square. So the area of a square is going to be side squared. So I know side length is 6. So I have 6 squared. Finish off the brackets. All that multiplied by the height, which they gave us and told us is also 6. So inside of my parentheses, I have 6 squared. And I'm going to do that first. So I have 1/3. 6 squared is 36. Multiplied by 6. So if you plug the rest of this into your calculator, you should get 72. And now I have the volume of my solid number 1 and my solid number 2. So we can use the volume addition postulate, which means we find the volumes of the parts, add them up, we'll get the volume of the whole entire figure. So we would do the volume of the entire thing would be 216 plus 72. That's going to give me a total volume. So my total volume is 288 meters cubed. 288 meters cubed.